afternoon. I'd like to welcome you to the PhD defense by Farooq Jan. The commission is complete. It's with Elvira Hermann, Markus Haug, Dirk Bölscher, Erwin Bergmeier, and Dirk Gansert. And yeah, so we are now at your final stage of your PhD, and Jan got a scholarship from his home university. It's the Abdul Wali University in Pakistan. He got a scholarship over 3 years or more to do his PhD, and he did his master in biology at the same university.
It
was another university. And during his master, he worked already on the Poaceae family, and so he had a lot of interest to go on with the Poaceae family. And when he came first to Germany, he started in Bochum, but then he moved to Göttingen and saw that we worked also on the polymorphology of Poaceae. So I think that was probably your interest to come to Göttingen. And yeah, and now is your time. So you know about the procedure. We have half an hour for your presentation, and then half an hour, 45 minutes for questions from the commission. And of course, you all can also later on have questions to Farooq. Yeah, please.
Thank you for a very nice introduction. I welcome you all to my presentation. My PhD topic is Palynological Studies and Holocene Ecosystem Dynamics in Northwestern Khyber Pakhtunkhwa Province of Pakistan in the Hindu Kush Himalayan region. I will briefly introduce the topic and the area, then briefly the results of the 3 papers I have included in my work, and conclusions, and finally your questions. So, Pakistan lies in South Asia, 23 to 37 degrees north and 60s to 70 degrees east. The country as a whole lies in the subtropic zone, with the south of the country touching the tropics, and the north of the country enters from subtropics to the temperate zone. But most of the country, overall, the climate here is subtropic. If we zoom this region, to the west of Pakistan lies Afghanistan, to the southwest lies Iran, to its south lies the Arabian Sea, India lies to the east of the country, and China in the north of the country. In the north of the country, 3 of the world's most important mountain ranges, that is the Hindu Kush, the Karakoram, and the Himalayan ranges, lie here. World's second highest peak, K2, lies in the north of the country, and world's topmost peak of Mount Everest lies somewhere here in Nepal. My research area is the northwestern part of Pakistan, and in the northwestern part of Pakistan lies the Khyber Pakhtunkhwa Province, and this is my research area. In this northwestern province, I have worked along a 200-kilometer elevation transit, and I have carried out all my 3 studies along this 200-kilometer gradient, starting from Peshawar Valley between Charsada and Naushera at 280 meters above the sea level. I have moved then to Mardan, then this is the plain area, and here starts the lower mountain area of Malakhand. This is the second elevational zone of my gradient. Then moving from Batkhela to Sawat area, this again above the lower mountain, this again is a flat valley. And then from Swat Valley onward, I have moved to the where starts the upper mountain area. I have reached to a height of 2,600 meters. The peak here reaches to 2,800 meters, but I have worked up to 2,600 meters in this area. My PhD topic, Palynological Studies and Holocene Ecosystem Dynamics in Khyber Pakhtunkhwa Province, comprises 3 sub-projects. In the first sub-project in this area, I have worked on Poaceae, and the title of this sub-project is Trends of Pollen Grain Size Variation in C3 and C4 Poaceae Using Pollen Morphology for Future Assessment of Grassland Ecosystem Dynamics. The questions which I addressed in this sub-project: can C3 and C4 species from different regions be separated by their pollen grain size? And what is the role of polyploidy in determining the pollen grain size in Poaceae? In total, I collected 160 species, including 98 C4 and 62 C3 species. Out of them, 70 species I collected from my research area. But when I brought those species here to Germany, we got this as a limited data set, and then our colleagues working in different parts of the world helped us, and we got 35 species from Tanzania to represent the African species, 25 species from South America, and 30 species I grew here in the botanical garden to represent the European species. And the idea was to look at pollen grain size variation in Poaceae on a larger or continental, larger spatial or continental scale. I dried all the 160 Poaceae species in newspaper, preserved them, mounted them on standard herbarium sheets, and using reproductive characters of the flowers and with the help of very able taxonomists and online search, I identified all the species. Using standard protocols, I received pollen grains from the flowers of all these species, and then under the microscope I measured 4 pollen grain parameters of each species, that is the pollen grain length, the pollen grain width, the pore diameter, and annulus width or annulus thickness. Then the question for measurement setting was that how many species do I need for a certain species to be sure about the size of a pollen grain of a species growing in a certain climate. Here is the stability graph showing that the median grain length stabilizes with increasing number of pollen grains. On the x-axis are increasing number of pollen grains. On the y-axis is the average pollen grain length in micrometer. And we see that initially for a few number of pollen grains to be measured for a certain species, there is a fluctuation. But after 30, there comes stability. And in my work, 45 pollen grains are sufficient to get the stability and come to know about the exact size of a certain pollen grain of a certain species. Then here I am showing only the major parameter, that is the pollen grain length. I have done it for all the 4 pollen grain parameters. But here is the measurement of pollen grain length in C3 and C4 diploids and polyploids. Upper I am showing the C3 species, and below are the C4 species. And here is the comparison in the measurement of pollen grain length between C3 diploids and polyploids. And we see, if we look at the frequency distribution histograms, majority of the C3 diploids fall in the measurement, their pollen grain length falls in the measurement range of 24 to 28 micrometers. But if we look at C3 polyploid species, for pollen grain length, the measurement range falls in 30 to 34 micrometers. If you look at C4 species and compare diploids with polyploids, here the measurement range falls from 30 to 38 micrometers, And in the case of polyploid species, the measurement range, the maximum frequency falls in the range of 34 to 40 micrometer. I performed statistical tests. Here are the results. Above I am showing C3 species and below are C4 species. And here for all the 4 pollen grain parameters on the y-axis, that is pollen grain length, pollen grain width, pore diameter and annulus width. Here is the comparison in C3 species between C3 diploids and C3 polyploids. And here we see that for pollen grain length, the difference between diploids and polyploid species shows significance, and same is the case for pollen grain width, but the difference in the other 2 parameters, that is the pore diameter and the annulus width, is not significant. In the case of C4 species, the comparison for all the 4 pollen grain parameters shows significance to a certain degree. Then I wanted to know how much is the strength of relationship between any 2 pollen grain parameters, which shows that the most stronger correlation exists between the pollen grain length and the pollen grain width on a scale of 0 to 1, followed by the correlation between pollen grain width and pore diameter, and the least relationship exists between these 2 parameters. But this shows that the 2 prominent pollen grain parameters, that is the pollen grain length and the pollen grain width, are sufficient to determine the pollen grain size of a certain species. I applied the linear discriminant analysis as it is best for discriminating a priori defined groups. Here, the histogram based on the 4 pollen grain parameters, and on the x-axis, this 0 is a threshold. To the left are the C3 species scores, and to the right are C4 species scores. And here is the comparison between C3 group and C4 group, where we see that 33% of C3 species, which lie to the left, show overlap with C4 species. And C4 group, which here lie to the right, show 12% overlap with C3 species. I made of this 160 data set another data sets and divided it into diploid and polyploid group, and then I found that here on this 0 threshold scale, where to the left lies the diploid group, showed 31% overlap with the C4 species scores, and the C4 with the polyploid group. And the polyploid group showed 16% overlap with the diploid group. I tried different type of multivariate analysis, but finally we decided with the non-metric multi-dimensional scaling to look at these scores from different axes if they are different. Or so here is the comparison between C3 and C4 species. And if we look at NMDS axis 1 and NMDS axis 2, the scores are not clearly separated, they show overlap. If we look at NMDS axis 1 and NMDS axis 3, again there is overlap, though there is separation. And the same is the case for when we look at NMDS axis 2 and axis 3, there is a huge overlap. And the same is the case when we look from all these 3 axes at the diploid and polyploid group. What we conclude from this work, that C3 and C4 species are not clearly separable based on the measurement results of these 4 pollen grain parameters, but the measurement results and statistical tests reveal some trends. And what are those trends? That C3 polyploids have larger grain size than C3 diploid species, and similarly C4 polyploids have larger grain size than C4 diploid species. In my data set of 160 species, polyploidy is more in the C4 than in the C3 species, and the C4 species have larger grain size than C3 species. My dataset is limited at only 1.45% of all the Poaceae family, but still shows a pattern in the pollen grain size variation, and this number needs to be increased for replicating the studies in the future. Grasslands are separable based on the pattern, looking at the pattern of their increasing or decreasing trends in their pollen grain size. The average difference in the pollen grain size taken from a core may indicate shifts between C3 and C4 Poaceae grassland composition during the past. And those results we can compare with the phytoliths, assemblages, and evidence from isotopic studies to know more about the past grassland composition. Poaceae pollen grains deposited in environmental archives may help us reconstruct past climate, assess the dynamics of past grassland ecosystems, and provide useful insight for future predictions. This is what I presented in the Open Landscape Conference in Göttingen in 2013, and it is published and it's available online. In the second project, which is tied to vegetation and pollen representation along the 200-kilometer transit in Khyber Pakhtunkhwa Province in northwestern Pakistan. In this sub-project, my questions were: whether the plant diversity patterns of the existing vegetations are reflected in modern pollen grain. Question 2, what are the key taxa of the different elevation zones as reflected in modern pollen grain? And the third question was whether the land use and human impact is reflected in the modern pollen grain. For this method, along the 4 elevational zones, I took them as 4 sampling areas. I did the vegetation survey using from Blanquet's scale. A total of 24 plots I established, 6 plots in each elevational zone. And I documented the percent cover of the taxa in this 10 into 10 meter plots. I also took surface samples from the plots, mixed them, and processed them in the lab and studied them under microscope and looked at the pollen. Based on a count of 300 pollen grains per slide, I then compared the percent pollen abundance with the percent vegetation cover in this transit. Here I am showing a little part of the vegetation cover data of these 24 railways. And these are the 4 elevational zones, and here are the 24 plots. And here is the details of the percent cover of the taxa in the plots. Then is the pollen diagram, whereby here we see the pollen abundance, and here is the elevation ranging from 275 up to 2,600 meters. And these are the 4 elevational zones. Here is the range of each elevational zone. And here we see that in the plant bed, the percent pollen abundance is maximum for Poaceae, including also the large size cereal grains, accompanied by Amaranthacea species Euphorbiaceae, Salutaceae, and Myrtaceae. In the lower mountain Malacan belt, here the percent pollen abundance was maximum for Sapindaceae species, for Asteraceae, Cannabacea, Barbaridaceae, and Verbenaceae species. And in the third elevational zone was Oleaceae, Boraginaceae species, Plantaginacea, Rubiaceae, Moraceae, and Bignoniaceae. And in the fourth elevational zone of Malanjaba, these were the dominant Pinus, Poaceae, Abies, Cedrus, Cyperaceae, and Balsaminaceae, and Eracea. So, if we are standing in a landscape where we don't have the clear ecotones, still we can draw vegetation boundaries based on the percent pollen abundance. I compared the percent pollen abundance with the percent vegetation cover of the taxa and at family level. And here we see that the percent pollen abundance, for example, of Poaceae in the plant bed, here I am showing only for a plant bed, this I have carried out for all the zones, is this percentage is double as compared to the percent cover of the taxa in the vegetation. And similarly for all the taxa, we can compare the pollen abundance with the percent vegetation cover. This comparison at family level is already established in the scientific community. Then I looked at the transfer factor values, dividing the percent taxon in the vegetation by percent abundance in the pollen rain. And if these transfer factor values show us that if a certain species which is more where the percent pollen abundance is greater than the percent cover of the vegetation, the transfer factor there will be transfer factor values will be lower than 1. And if a certain taxa where the vegetation cover is more as compared to the percent pollen abundance, the transfer factor values will be more than 1. And here they will be less. The scatter plots showing, if we focus at individual families and look at the scatter plots and compare the, look at the percent vegetation cover and the percent pollen abundance, then we can see, okay, which family, where this correlation is significant, in which family, and in which family the relationship is not significant. And pointing out such families, then we can hypothesize further questions looking, because we already have the percent cover data of the taxa or species in the vegetation, and then based on those we can hypothesize further questions. What are the conclusions? The pollen rain signal reflects the plant diversity pattern. 2. Relationship between pollen rain and vegetation are comparable at their family level. 3. 4 distinct irrigation zones are defined by dominating plant families. 4. Pollen grains of cereals, Brassicaceae, Amarantaceae, Cannabaceae reflect the proximity of human habitation in the lower 3 zones, while Pinaceae, Pteridacea, Dwarf Pteridacea reflect natural vegetation in the upper mountain Jebel zone. The differences in the representation of plant families are measurable as transfer factors, and such transfer factors can be applied to calibrate palaeorecords in future studies, enabling us to quantitatively reconstruct the past climate and vegetation. This paper work I presented in the Tropical Ecosystems Conference in Zurich this April, and this paper is accepted in the journal with minor revision. The third study, entitled Holocene Vegetation and Climate Dynamics in Khyber Pakhtunkhwa, northwestern Pakistan, input from the Kabul swat pollen record during the last 3,300 years. And the question here was, how were the past vegetation patterns and the climate driving factors in Kabul swat area? So, Kabul swat starts at the beginning of the third elevational zone at 750 meters above the sea level. To the west of, here I took the core, to the west of this coring site lies the Swat River, and to the east of the coring site lies the Kabul village. And around this coring site, the major or important taxa are Pinus in these hills are Pinus roxburghii, Pinus Walisiana, Poaceae martiana, Cedrus deodara, Aedes pendro, Quercus semicarpifolia, Juniperus jubilus species, and some others. There are others, but I'm showing the important ones. I took a 150 centimeter core from this covered area with Russian coral, and I got the ages of 4 radiocarbon dated samples. At 55 centimeter, the core showed the age, the sample showed the age of 883 years. At 82 centimeters, it is 3,756 years. At 148 centimeter, here it is 8,103 years. And looking at the age, that model here is the depth from surface up to 150 centimeter down, and here are the ages. So beyond 80 centimeters down, there was less pollen preservation. So I worked on a total of 38 samples, but as there was less preservation downwards 80 centimeters, so I worked with the top 20 samples, and I fitted a linear